7.2, Properties of Parallelograms. Essential question, what are the properties of parallelograms? A parallelogram is made up of both pairs of opposite sides being parallel. Let's take a look at this picture. You can see the arrows are showing parallel and parallel. In fact, the word itself has the word parallel. A definition is always a biconditional. So parallelogram, we use the symbol for parallelogram if and only if both pairs of opposite sides are parallel. For today's lesson, we're going to be more concerned about knowing that it's a parallelogram and what are the features or characteristics do we see. So we're going to be working in this direction. If you have a parallelogram, then we know both pairs of opposite sides are parallel. What else can we discover about the parallelogram? Well, another theorem that we have is that if you have a parallelogram, then opposite sides are congruent. That means this side's congruent to this side, this side's congruent to this side. And if you have a parallelogram, then opposite angles are congruent. So this angle is congruent to this angle, and this is congruent to this. Let's take a look at the proof for the 7.3. Okay, we have a parallelogram, and a parallelogram means that we are going to have parallel lines. These parallel lines right here are going to give us alternate interior angles that are congruent. Alternate interior angles are congruent. So we'll have a pair of angles, which we list here, and another pair of angles, which we list here. We also have a reflexive side, reflexive property. So the triangles are going to be congruent by angle, side, angle. And once the triangles are congruent, we get this side congruent to this side, and this side congruent to this side by corresponding parts of congruent triangles are congruent. All right, so let's go ahead and try to find x and y. We know that opposite sides are going to be congruent, so I'm going to know that x plus 4 will be equal to 12, so x is equal to 8. I also know opposite angles are congruent, so that means y will be equal to 65. Okay, now your turn. Stop the screencast and see what you can do. And here are the answers. What else can we say about a parallelogram? Well, another thing we can say is once we have a parallelogram, we know that consecutive angles are supplementary. So these two angles, consecutive angles, are supplementary. And that's true about all parallel lines. So this is not surprising. The other thing that may surprise you is if you have a parallelogram, then the diagonals bisect each other. So this diagonal will cut this in half, and this will cut this in half. So this point right here where they both intersect is going to be a midpoint. Let's go ahead and prove that in this next theorem. All right, so we have a parallelogram, which means we have parallel lines. This line right here, PQ, is parallel to this side, which is SR. Now that's going to create some alternate interior angles that are going to be congruent, which I've indicated right here. We also have a pair of sides congruent because if you have a parallelogram, then opposite sides are congruent. So this is going to give us angle, side, angle. Once that's true, then we know that this part is congruent to this part, and this part of the triangle is congruent to this part by CPCTC. And when that happens, that's telling us M is going to be M is the midpoint, and it's the point at which the two diagonals cut each other. All right, let's take a look at this picture. This is a parallelogram, and we want to find, we know ADC, that's this angle, and we'd like to figure out BCD, which is this angle. Now notice that we're going to use the theorem about consecutive angles. So if this is 110, then that other angle is going to be 70. Now here's a proof. Let's see what you can do. Stop the screencast and see if you can fill out the reasons. And here are the reasons. Notice that we have two parallelograms, so both pairs of opposite angles are congruent. This angle is congruent to this angle is congruent to this angle. But we know that these two angles right here, this one and this one, are vertical angles. So that's going to be the connection between these pairs, that they are going to be congruent, and therefore angle B is congruent to angle F by the transitive property. Let's look at a coordinate proof. I plotted the points and we want to find the coordinates of the intersection of the diagonals. We want to know where these diagonals intersect. So let me go ahead and draw the diagonal here and then draw the diagonal here. And we'd like to use a coordinate proof to do that. All right, so I'm going to use midpoint. So I'm going to figure out the midpoint of OM. Here's O and here's M right here. And so that's going to be, I'm going to add the two x's and then divide by 2. And then add the two y's and divide by 2 here. Now let's do the same thing for ln. I'll go ahead and put it in a different color, L and N. And I'm going to add up the two x's and then divide by 2. Add up the two y's and divide by 2. Now I really only had to find one because we know the other one has to be the same as well. Okay, let's look at this problem. We have 3 points and we're being asked to find the third point. So we want to do W, X, and somewhere Y is over here, and then Z. So this is what we want, W, X, Y, and then Z. Well, I know that the opposite sides are parallel. So I know that for this side right here, I go down 1 and over 1, 2, 3, 4, 5. So from right here, I'm going to want to go down 1 and then go over 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so when I do that, then this will be my point Y, and that is the point 2, 1. So 2, 1 will allow me to create this parallelogram. So I'm going to go ahead and connect and then connect right here. And you can see I do get a parallelogram right there. Okay, your turn. Go ahead and see if you can find the intersection of the diagonals. Stop the screencast. And here's the answer. Notice that I only had to find one of the midpoints because the other one will be exactly the same. Your turn to find the coordinate of D. Plot the points and see if you can find it. All right, now to find D, I plotted 3 of the points, and remember what I want to do is make sure that the opposite sides are parallel. So over here from this point, I'm going to go 3 units to the left and 2 units up, and that's what I want to do over here. I'm going to go 3 units to the left and then 2 units up, and this will be my point D, and point D is 0, 1. And that'll give me a parallelogram. And there we go. Okay, here's the summary. Let's see if you can summarize all the things that we know about a parallelogram. Stop the screencast and see if you can write it. And here are all the answers. The first one comes from the definition of parallelogram, and all the others are theorems.